Africa is tearing apart. In 2025, scientists watched in real time as the ground in Ethiopia cracked open. Fissures wide enough to swallow roads and rattle villages. This story is unfolding beneath people's feet right now in one of the hottest, harshest landscapes on Earth. And what's driving it? A hidden force deep beneath the crust, pulsing upward like a heartbeat, its jolts recorded in seismic data collected just this year. If you've ever wondered what it looks like when a continent begins to split, this is it. To understand, we need to go to East Africa. I'm Mark Watts, welcome to Deep Science. This is the Afar region, a landscape that feels almost otherworldly. Temperatures here soar above 115 degrees Fahrenheit or 45 degrees Celsius. The ground shimmers with heat and vast salt flats stretch endlessly to the horizon. In the distance, volcanoes dominate the skyline. Some active, others long silent, but scarred by ancient eruptions. And then there is Erta, a lava lake that has burned for decades in the heart of Afar, one of only a few like it anywhere on Earth. Its surface never rests, crusts of rock form and tear apart. It is beautiful and terrifying at the same time. Few places on Earth bring us this close to the living core of the planet. Yet despite its harshness, this land has shaped us. Fossils of Australopithecus afarensis, our ancient relatives, were found around here. The famous skeleton Lucy was unearthed in this very ground. In a sense, Afar is both the birthplace of humanity and the stage for Earth's next geological act. Geologists call this place a triple junction where three tectonic plates meet: the African, the Somali, and the Arabian. It's a collision of boundaries, three puzzle pieces pulling apart at once. Beneath the surface, rising heat from the mantle weakens the crust, while old fractures give it places to split. Together they've created one of the most unstable regions on the planet. Think of it like a wooden table that's already been scratched and scored. Press hard enough and it will split exactly along those old weaknesses. That's what Afar is doing. Only instead of wood, it's entire slabs of continent cracking along ancient scars. The region is a living laboratory where we can watch in real time how continents begin to rupture. But how does this process actually work? What forces are tugging, stretching, and breaking Africa apart? The secret lies in plate tectonics, the giant slabs of Earth's crust that rest on a softer layer beneath. They drift only centimetres each year, about as fast as your fingernails grow. But over millions of years, that slow motion reshapes continents. In Afar, those forces are on full display. The land isn't really gently easing open, it's under tension rather, pulled in several directions at once. And like dough being stretched too far, the crust begins to thin, tear, and eventually split. Only here it's solid rock ripping apart. The East African Rift itself has two main branches, the eastern arm running through Ethiopia and Kenya, and the western arm slicing along lakes like Tanganyika and Malawi. Each branch behaves a little differently. Some segments break dramatically with earthquakes, others leak lava more quietly. Together, though, they form a scar across the continent, one that is lengthening every year. And when plates stretch too quickly or unevenly, the stress can release all at once. The ground jolts, ruptures, and sometimes collapses in spectacular fashion. That leads us to a moment 20 years ago when the Earth quite literally cracked open before people's eyes. What exactly happens when the rift decides to move suddenly, not over centuries, but in just a few days? In 2005, scientists and locals in Afar got their answer. A series of earthquakes rattled the region, followed by a deep rumble from beneath the Earth. Then it happened. A colossal crack tore across the desert floor. In less than 2 weeks, the ground split open along a line nearly 37 miles or 60 kilometers long. Imagine driving down a highway one day only to find the road has dropped into a jagged canyon the next. That's how abrupt it was. And this wasn't really happening on the surface. Underground, a massive dike, a blade of magma slicing upward, forced its way through the crust. Picture molten rock like a fiery crowbar, prying apart solid stone as it rises. That dike injected itself between the plates, widening the rift by as much as 8 meters in some places, almost overnight. For scientists, it was both alarming and exhilarating. They had theorized that Africa was splitting, but here was the proof unfolding in real time. Teams rushed in to measure the fissure, track aftershocks, and sample the fresh lava. For villagers living nearby, though, it was a frightening reminder that their land is not stable ground at all. It's the front line of Earth's tectonic power. But for geologists, the 2005 crack was part of a bigger pattern, evidence that something deeper is driving this system. Because if the surface can split open so quickly, then what hidden force is pushing magma upward with such relentless energy? To answer that, we have to descend into the depths of the Earth, where a colossal plume of heat and molten rock pulses like the heartbeat of the planet. Down here, the world is alien. Rock is solid, yes, but under crushing pressure and immense heat, it flows like tar. Rising through this mantle is something extraordinary, a plume of hot material. A slow-motion blowtorch pressed against the base of Africa. For tens of millions of years, it has softened the crust and primed it for the split we see today. But here's the remarkable part. It doesn't rise steadily, it pulses. Like a kinked garden hose, pressure builds, then surges through. The Afar plume works the same way, sending bursts of heat and magma upward. Each surge forces the crust to bulge, crack, and sometimes tear open, as it did dramatically in 2005. So how do we know this isn't just theory? Earth leaves clues. Seismic tomography, essentially an ultrasound of the planet, shows slow seismic waves beneath Afar, the hallmark of hotter, softer rock. Lava chemistry adds detail. Some samples contain isotopes that trace back to astonishing depths, perhaps near the core mantle boundary. That means it's connected to Earth's deepest reservoirs. And even satellites can see the pulse. GPS stations measure the land drifting apart by millimeters each year. Some areas rise, others sink, as though the surface itself is breathing. Put it all together and the message is clear. The Afar region is the visible edge of a deep living underground engine reshaping a continent. But deep plumes and seismic scans can feel abstract. What about the things we can actually see? The volcanoes, the fissures, the trembling ground beneath our feet. What does all this look like on the surface? In Afar, the signs are everywhere. Volcanoes rise from the desert floor, some belching steam, others lying quiet but draped in fresh black lava that flowed only decades or centuries ago. Each cone, each crater, each lava field is a marker of the plume's heartbeat breaking through. Then there are the rocks themselves. Geologists collect shards of cooled lava, pumice, and volcanic ash. Inside are minerals that act like time capsules, recording the pressure, temperature, and depth where the magma formed. Analysing them is like reading the diary of the Earth's interior, evidence that matches what seismic scans suggest below. The ground is restless too. Networks of seismometers pick up hundreds of tiny earthquakes each year. Most are too small for people to notice, but together they reveal the constant cracking and shifting of the crust. And then there's the slow reshaping of the land. GPS receivers bolted into bedrock show the rift widening by millimeters every year. It doesn't sound like much about the speed your fingernails grow, but scaled up over centuries, it's enough to split valleys, tilt lakes, and reshape entire landscapes. Even satellite images show Afar is sagging downward, as though the ground is being pried apart from below. All of these clues tell the same story. The pulses rising from the deep mantle are leaving fingerprints at the surface. Volcanoes mark the exits, rocks hold the recipes, and earthquakes whisper the stress building below. But if the land keeps stretching, if valleys keep sinking, what happens when the cracks finally reach the ocean? At some point, the land in Afar will drop low enough for water to rush in. The Red Sea or even the Gulf of Aden will spill inland, flooding the Rift Valley and creating a brand new ocean basin. Imagine standing where desert now stretches for miles and seeing waves rolling in, forming an entirely new coastline. Geologists believe this is Africa's future. The continent will split in two. On one side, most of Africa. On the other, a new landmass carrying parts of Ethiopia, Somalia and the Horn of Africa. Between them, a young ocean slowly widening year by year. The timeline? That's the tricky part. Some models suggest it could happen within tens of thousands of years. Others say hundreds of thousands. In geological terms, though, that's the blink of an eye. And if the 2005 crack taught us anything, it's that the process doesn't always move slowly. Sometimes change comes in sudden leaps. We've seen this kind of transformation before. The Atlantic Ocean itself began as a rift, much like Afar when South America pulled away from Africa. What was once dry land fractured, dropped, and then flooded, becoming the ocean we know today. So Afar may be offering us a rare window into the birth of an ocean. One day, future maps might show a blue gulf where today there is desert, reshaping trade routes, ecosystems, and even climate. It may sound distant, but Africa's split is a chapter in Earth's ongoing story. A story that connects continents, climates, and ultimately, us. So why does this matter beyond Africa? Because the forces tearing at Afar don't stop at national borders. They ripple outward. When rifts move, they generate earthquakes that can devastate nearby communities. When volcanoes erupt, they throw ash and gases into the atmosphere, disrupting air travel and even shifting global climate. A single large eruption in East Africa could cool the planet for months. And then there's the human side. Millions of people live along this rift system, their farmland. Homes and water supplies depend on stable ground that is anything but stable. When a crack opens across a road or a village, it is a direct threat to daily life. But there are opportunities hidden in the danger. Rift zones are rich in geothermal energy, a clean and powerful resource drawn directly from Earth's heat. Understanding how the rift works could help countries across East Africa tap into that energy safely. But as much as Africa's rift may feel unique, it's really one chapter in a much bigger book. Earth is splitting in other places too, right now. Take Iceland. There, the mid-Atlantic ridge runs right across the island where the North American and Eurasian plates are drifting apart. You can actually walk through rift valleys in Tinkvetlir National Park, 1 foot on each continent. Volcanic eruptions, geothermal energy, and even hot water geysers all stem from the same process that is reshaping Africa. And there are hints elsewhere too. The basin and range region of the western United States is being stretched, its valleys and mountain chains formed by crust under tension. But here's where things get interesting for my viewers in the US. The Gulf of California, already an active rift, is creeping slowly northward toward this region. Some geologists believe the rift could eventually extend into the basin and range, carrying seawater into what is now dry land. In geologic terms, Arizona itself could one day sit on the edge of a brand new ocean basin. Seen this way, Africa's rift isn't an isolated curiosity. It's part of a cycle that has shaped our planet for billions of years. Continents assembling, breaking, drifting, and colliding again. Afar just happens to be one of the rare places where we can watch this grand cycle unfold in real time. And that's what makes it so extraordinary. Usually the birth of oceans and the shattering of continents are events we only read in the rocks, long after they've happened. In Afar, the story is unfolding as we live and breathe. Cracks open, volcanoes erupt, valleys sink, all small steps in a process that will eventually redraw the map of the world. For us, bound by lifespans measured in decades, it's easy to forget how fast this planet moves on its own clock. 1,000 years is ancient history to us. Yet to the Earth it is barely a heartbeat. We will never see the day Africa finally splits, or the new ocean that will flood its deserts, but knowing it is happening gives us perspective. It reminds us that our lives are brief, fragile flashes set against deep time. And yet for this moment we are witnesses to Earth in motion, sometimes slow and silent, sometimes in sudden, spectacular bursts. One of those bursts left a mystery behind. On the shores of Tonga, a massive boulder sits high on a cliff, too heavy for humans to move, too far inland to be simply washed ashore. So what force was powerful enough to throw it there? Find out in this video.